My name is Moritz. Thank you for attending my pre-recorded talk. Over the next 20 minutes, I would like to take you on a little ride. Please use the pause button if I'm driving too fast. First, I will sketch a view regarding the core methods of philosophy: argumentation, concept formation, and the posing of questions. My recognition of the importance of formal methods in philosophy pushes me to provide an overarching formal framework which accommodates argumentation, concept formation, and the posing of questions alike. Second, I will mention some problems in question logic. Third, this builds to what I consider the main problem of the philosophy and logic of questions: the regulation of the activities of asking and answering. A common conception of philosophy conceives of argumentation as the core activity of the discipline. To philosophize is to argue a certain topic. While this is widely accepted even among the interested laity, it is really manifest in practically all textbooks on philosophical logic and the university courses associated with them. Logic courses are about declarative statements and how they relate via deduction and entailment. I believe that this primacy of argumentation is not justified. My alternative view is this: in philosophical methodology, argumentation is to be treated as roughly equal to the formation of concepts and the posing of questions. Take, for example, concept formation. My favorite example is philosophy for middle and high school students or for university students from other disciplines. In such a context, argumentative discourse comes only after the relevant concepts are somewhat clear. And frequently, the grasping of the relevant concepts by and for the students is the primary goal, whose attainment suffices for a successful lesson. Now take questions. When looking at some of the great philosophers, it is obvious that questions and practices of asking and answering questions are at the heart of their works. Plato's Dialogues, Aristotle's Topics, the scholastic Disputationes, the scholastic Summae and their Questiones, the Cartesian doubt and how it is frequently formulated as question escalation, the opening sentences of Kant's Critique of Pure Reason, the Vienna Circle's critique of perceived pseudo-questions in metaphysics. As a corollary of my view, I see a need to reconsider the formal methodological education of philosophy students. If questions and concept formation are about as equally important as argumentation, then logic courses should strive to formalize not only the argumentative portions of philosophy. Concept formation is, of course, already present in parts of the mainstream of philosophical logic, although it progressively vanishes from logic textbooks. Here's a diachronic pie chart for definitions in symbolic logic textbooks over the last 100 years. Focusing on the positive aspects, there are normal form definitions, axiomatics, criteria of eliminability and non-creativity, and so on. In short, concept formation includes some concepts which function as a kind of standard, in analogy to how first-order logic can be a standard for argumentation. In contrast, pretty much everything around questions is controversially discussed. This might be one reason why it rarely ever appears in logic textbooks. There are several quite elaborate approaches to question logic which are each mutually incompatible, at least at the surface of it. Michael Pellish used the appropriate word multi-paradigmatic. The philosophy and logic of questions is multi-paradigmatic. Let's get to the foundations of a common formal framework. For the following, I will take a little detour, so please bear with me. Elsewhere, a colleague and I have argued that many calculi of natural deduction suffer from a common problem. They are in need of meta-language supplementation in order to allow for unique readability of their derivations. Such supplementation can come in the form of dependency indexes or graphical subproof markings like boxes or lines, or other means that are frequently not considered part of the formal object language. Here's a simple example. P, Q. How is such a beginning of a derivation to be read? Since no inference rule allows one to infer P without premises, line 1 must be an assumption for the purpose of a conditional or an indirect proof. Similarly for the second line, since by no inference rule Q can be inferred from P, the second line must be the beginning of a conditional or indirect subproof. So line 2 is an assumption too. Now let us assume that the putative derivation continues thus: P and Q. No explicit reference to a rule is needed for you to know that this is an inference by conjunction introduction. Let us now suppose that the derivation gets a little bit inane. P and Q and Q. You will probably say that this is just another conjunction introduction. In total, you will say this sequence is a derivation of P and Q from the set whose only two elements are P and Q. The next step is a bit surprising. P and Q, then P and Q and Q. Of course, line 5 contains logical truth. But when asked about the correctness of this derivation, you should consider the immediate premises of the supposed conditional introduction. The antecedent comes from line 3, an inferred line. But inferred lines do not turn into antecedents by means of conditional introduction. So maybe line 3 was an assumption after all? Well, it should be read as an assumption if line 5 is supposed to be correct. It appears that one has the choice between, on the one hand, regarding line 5 as an incorrect inference, or, on the other, admitting to one's own fallibility with regard to the intuitive assessment of the 3 and the 4-part sequence. At the bottom of this fallibility is, of course, an ambiguity of line 3. One cannot tell whether this line is an assumption or an inference. But once this ambiguity has been spotted, the fallibilism must be extended to all the other lines too. For all we know, whoever has written down these 5 lines here might have intended for them all to be assumptions. So the execution of 2 conjunction introductions was just a superficial appearance? Although the problem is rarely ever recognized as such, its remedies are well known. One can simply state the rules which cover each line. Alternatively, one can use boxes or numbers to indicate where subproof begins and where, consequentially, assumptions are to be found. However, these and some other solutions rely on the meta-language commentary, or invented ad hoc devices like boxes or lines. These are not the devices by which ambiguity is avoided in natural language. So, how is ambiguity avoided in natural language? There are 2 readings to the above sequence which one might employ when paraphrasing this, for example, when giving a student an intuitive impression of a formal derivation which is taken to be correct. Suppose P, suppose Q, suppose P and Q, thus P and Q and Q, thus if P and Q, then P and Q and Q. Here's a second reading. Suppose P, suppose Q, thus P and Q, thus P and Q and Q, thus if P and Q, then P and Q and Q. The student would be right in sensing an incorrect inference in the second reading, not in the first one. At this point, the logicians have to ask themselves, why in the process of formalization are we deleting expressions like suppose and thus only to introduce boxes, indexes and other artificial devices? I suppose the answer is to be sought deep in the history of modern logic. I said something about this elsewhere, so for now I would like to concentrate on the takeaway, which is we should not delete expressions like suppose and thus. We should have them as logical expressions in our first-order languages. I take it that it is not difficult to see that their inclusion is only a marginal change to the appearance of propositional or first-order logic. You can take marginal in a literal sense here. Just put suppose and thus at the left margin, prefixing each statement in a derivation, and you are practically there. For those who feel this is too wordy for symbolic logic, you can also use single characters. What does this have to do with the inclusion of concept formation and the asking of questions? Obviously, suppose and thus are illocutionary expressions, indicating the performance of the speech act of assuming or inferring, respectively. Taking another cue from speech act theory, defining, postulating, asking, and possibly answering are simply other kinds of speech acts. One may wonder, is there a framework which accommodates different kinds of speech acts in a uniform fashion? In a first step, one can recognize expressions which signal the various kinds of speech acts to be accommodated while leaving the treatment of their content to the customs of declarative logic. Suppose and thus are 2 examples of such signal expressions. If one calls them performators, one can jot down the elements of this performator category suitable for a first-order framework which allows for the formal representation of the activities of argumentation, concept formation, and question asking. Here's the performator category. Suppose, thus, claim, since, axiom, def, which, and whether. Let us establish performators are unary operators. They are applied to formulas. They cannot be iterated, Thus, the expression resulting from the application of a performator to a formula cannot be the object of another application of a performator. This means that formulas and the results of the application of performators to formulas are two mutually exclusive molecular categories. In the tradition where performators are recognized, it has become custom to reserve the word sentence for the results of applying performators to formulas. The framework thus sketched will be called the pragmatized framework. I now come to the problems in question logic. As stated earlier, arithmetics constitute a multiparadigmatic field within logic. There is Wisniewski's inferential arithmetic logic, Ciardelli, Grönendijk, and Orlovson's inquisitive semantics, Hinteker's interrogative model of inquiry, Grönendijk and Stockhoff's partition semantics, Belknap and Steele's categorical approach, Orquist's imperative epistemic approach, Harar's purely declarative reduction of questions, Hartmann's constructive question logic, and some more. So the above sketch of a common category of illocutionary expressions for the deductive, definitional, and interrogative parts of logic is only the beginning of a unifying formal implementation of argumentation, concept formation, and the asking and answering of questions. I see at least 3 tasks emerging from discussions in arithmetics which directly relate to the specifics of the pragmatized framework. I will formulate them as meta-questions. First meta-question. Shall a logic of questions regulate the posing of questions exclusively, or shall it regulate the giving of answers too? Instead of motivating my answer, I will simply provide it here. Arithmetics can contribute to the regulation of answering, but this contribution is deferred due to the extra-logic character of answering obligations, and due to the fact that answers are often inferences, definitions, or the like, where these speech acts are regulated by their own rules. Second meta-question. Do questions have a content the same way as assertions and inferences do, or are questions inherently incomplete? Without further argumentation and despite views to the contrary, I take it that yes-no questions do have a complete content. With WH questions, this is less plausible. Who killed JFK essentially contains what could be called an incomplete proposition, which could only be formalized by means of an open formula, killed X JFK. If this open formula does not express a complete proposition, then should one be allowed to apply a performator at all? In speech act theoretic terminology, is there an illocution without locution? I opt for allowing the application of performators to formulas like this one. In fact, this is done in many ND calculi anyway. The standard proof of a universally quantified conditional for all x, if fx, then gx, begins with the assumption of a generic instance of the antecedent, fx. The generic aspect is implemented by the use of a parameter, which may be considered a special purpose variable. So formulas with parameters are operands in assumption sentences anyway. Parameters can serve the same purpose in WH questions. Third meta question. What kinds of questions are to be distinguished? First, note that yes-no questions and WH questions are different from a speech act theoretic point of view. Yes-no questions can be interpreted as necessitating confirmation or disconfirmation of a presented proposition, and this might come with the burden of proof of the proposition or its negation, respectively. WH questions necessitate a selection, which might come with a burden of heuristical justification, possibly in addition to a burden of proof. So from a speech act theoretic point of view, yes-no questions and WH questions are different, because they necessitate responses that are speech act theoretically different. Once this line of reasoning is accepted, one can establish other kinds of questions. Why questions, for instance, might be regarded as necessitating explanatory answers in the sense of an explanation of Hempel and Oppenheim. These 3 meta-questions are preparatory to what I would think of as the main problem in question logic. What can be asked? In other words, picking up on the foundations of the pragmatized framework, what are the rules of performing acts of asking? In yet other words, picking up on ideas in arithmetics, how are consequence relations between questions to be defined? Here I understand consequence in a very wide sense. In order to relate this to the demand for rules of asking, consider consequence to be a scope concept associated with the scope of action, usually with the scope of what can be inferred, in this case, with the scope of what can be asked. Consequence relations of some kind have been proposed in arithmetics most prominently by Andrzej Wisniewski in his inferential arithmetic logic, IEL for short. There are basically two prominent consequence relations in IEL: evocation and arithmetic implication. Evocation relates sets of statements to single questions. Arithmetic implication relates questions and sets of statements to questions. There are certain technical and philosophical problems with the specifics of these proposals, which I have discussed elsewhere. Let me focus on the general picture of the posing of questions thus adumbrated by IEL. The questions to the right of the turnstile can be posed because they bear a certain relation to what is to the left of the turnstile. For instance, in both cases, it must be guaranteed that the question to the right has a true answer. From this, one can derive a first rule of asking. One may ask only those questions which are guaranteed to have a true answer. This seems like a reasonable rule for many purposes. However, it should be recognized that for some purposes, this already is too much of a limitation. In fact, sometimes one wants to be maximally liberal. One may ask anything. Anyway, evocation points to another desideratum for questions, which can be formulated as a rule. One may ask only those questions which have not yet been answered. In arithmetic implication, there is a different requirement. One may ask only those questions whose answering will help with the answering of another, as of yet unanswered, question. Basically, inferential arithmetic logic, by defining evocation and arithmetic implication, chooses two specific combinations of the four requirements just presented in order to get a fruitful meta-theory of questions. But there are more possibilities for question requirements. One may ask a new question only if no other question is currently unanswered. One may ask only those questions, a narrower question than which has been answered in the negative, and so on. As a philosopher interested in questions, I feel that at this point informed decisions need to be made. Means-ends relations in the asking and answering of questions need to be made explicit. In short, this is where the action happens. For the purposes of this talk, it shall suffice to have a number of proposals brought to the table. I project the following research avenue. In the philosophy and logic of questions, we should ask ourselves, under what circumstances would we countenance asking what questions? And this question can be answered by purpose-specific rules. In a given cognitive situation, the adoption of such rules amounts to a self-regulation or a standardization of practices of cognitive conduct. In closing, I emphasize the constructivist approach of my proposal. First, it is constructivist because it sets the arithmetician's focus to rules of asking. Such rules should, of course, be constructive in the sense that there's only a direct way to answer a question, and not an indirect one, for example, via model theoretic apparatus. Second, it is methodologically constructivist because it sees the setting of formal rules as a constructive standardization procedure departing from ordinary language. Third, the pragmatized framework allows us to arrive at a unifying formal language which is purely object language and not too far away from the practices in ordinary language. As such, our activities in the formal language can be seen as constructive steps toward a specific epistemic cognitive outlook in which questions play a central role. Thank you for watching.